Assalamu alaikum. Hello everyone. This is our fifth class of CS224 and today's topics are gonna be totally about R-type instructions. We're gonna generate the machine instruction for hex code and we're gonna convert the hex code to a machine instruction. First of all, I'm gonna start with this one, which is generate the machine code. The line is too big. Anyways, so basically how to change this code to a machine instruction, this is what we're gonna be doing. How to, when you execute it, you have the basic here, right? Sorry, yeah, the basic here, which is and $8, and $8 means you go to number 8, it's T0, and it's the same, and so on. It goes for the rest, T1 and T6. So this is gonna be T9, and then add 5 here, so I think it's gonna be T4. Let's check, T6, T14, my bad, yes. Alright, so this is basically how to change this line of code and T0, T1, T6 to this hexacode instruction. And this is what I'm going to be doing right now. So basically how to solve this question, as I wrote earlier, I'm going to need this line of code. I'm going to need to know the opcode of the AND instruction that I'm going to, I have my instruction as AND and then some registers, right? So I need three stuff. First of all, I need to know the operation and make sure that it's like R-type, because there are other ways to change a code from I-type format and J-type format, like they're built different. So right now we're gonna just focus on R-type format. So you need to make sure that it's, sorry, not this one, we said it's AND, right? You need to know the operation, you need to know the function, because that's a good hack. Any R-type instruction is gonna have opcode of 0. If you're gonna check, we have an R-type instruction here, the opcode is 0. The opcode slash function. So the first number is the opcode and it's 0. The functions, of course, are different, because if they're the same functions, if they're the same function in hex numbers, the computer is gonna be confused and it won't know which one to do. So we have here another R instruction, as you can see, 0 slash, and the opcode is 0. Yeah, I forgot to say that the functions are only for R-type instructions, and the opcode is a must in R-type, I-type, or J-type, but you won't care about this right now. We're just gonna care that R-type has opcode and a function. The opcode of an R-type is always 0. Okay, now I have everything I need. I have oh wait, I totally forgot something else. Let me bring it and come back to you guys. Do you guys remember when I said that this table is gonna be so important? Actually, we're gonna use it a lot in this question and also in this example video. We're gonna use it a lot in this video and also in the next step. As I said earlier, we're gonna change an instruction to a code, and we're gonna change a code to an instruction, and that's why this table is gonna be so important. All right, now we are done. Let me start doing my thing. So first of all, we're gonna look at AND code inside the data sheet, which is green sheet. I copied it here, so we don't need to go to the green sheet. It's an R type. As I said earlier, we're gonna focus on R type for today. So the first register is an RD. As you can see, the first register is an RD. So T0 is an RD. What is T0? If you go here, you're gonna see that T0 starts at 8. So this is like 8, 8. And then we have R, register RRS is T1, right? And now we have RT here. T1 is, so T0 is 8, T1 is 9, and T6, as I said earlier, is gonna be 14. So that's what we need to know right now. Now we need to know the opcode. We said the opcode for our registers are always 0, right? And then we have functions, and it's 24 in hex number. That's the first step. Remember that I used this table to get the numbers of the registers. As you can see, T0 is 8, T1 is 9, because 8 between 5, because from T0 to 7, from T0 to T7, it's gonna start from 8 and it's gonna end at 15. And between them there is T1, and T1 is after T0, it's 9. As I said earlier, I'm just repeating myself so it's clear. And T6 is 14, because T7 is 15, so T6 minus 1 is gonna be 14. Cool. Now let's go to the second step. As you can see here, there is something called basic instruction formats, and this is how the computer reads the code that we write and change it to hexa numbers. All right. So basically, for R type instructions, as I said earlier, there are three types of instructions: R, I, and J. And today we're just gonna focus on R types of instructions. So R type instruction has an opcode, it has an RS, RT, and RD. Shift amount, SHAMT is actually shift amount, and then function, which makes it unique for R type. As you can see here, as you can, sorry, oh, okay, as you can see here, opcode slash function. The only format that has slash after its opcode is R type. As you can see here, there's 21, 24, and R here 08, another R here 27, another R here 25, R here 2A, and so on. I think it's clear. All right, as you can see, I took the R format in front of you guys. It's here right now to explain it in a better way or an easier way. So the opcode is actually 6 bits. These are bits, okay? These are bits. So opcode is always 6 bits. It takes up to 6 bits. RS, RT, RD takes also to 5 bits each one. So RS is 5 bits, RT is 5 bits, RD is 5 bits, and then SHAMT, which stands for shift amount, takes 5 bits, and then we have function, which takes 6 bits, but we're gonna change these 6 bits to hexadecimal number. Therefore, it's gonna be only, okay. So 6 bits means two hexadecimal numbers, because each number takes up each hexadecimal number takes up 4 bits. I think it's clear. Now let's start doing the work. As you can see here, I'm just gonna copy this place and I'm gonna put it over there so it becomes easier to explain. I just needed the green sheet to know each register location. Where does it locate in the instruction, right? Wait, let me do it in another color so it's easy. I just needed the green sheet here, like this part of the green sheet here, to know where does each register locate in my instruction. And then after this, I give the numbers to these instructions, 14, 9, 8 from the table. And then after this, I'm gonna copy this, which what I got, and I'm gonna use it with how R-type format are actually built in the computer. Okay, now I hope it's clear. I'm gonna explain it before I start solving. So here is how R build should be used. Sorry. Um, yeah, here is how R type instruction should be written in this format. There should be opcode first, RS second, RT, RD, shift amount, and then function, right? And this is in hex. This is very important. It's in hex. All right. Then this is how and instruction is written. All I just did is just copying the code and T0, T1, T6. I translated this T0, T1 to T6 to numbers which are given from the table over here, this table, right? And then after this, where were we? We were here, right? After this, yeah, this is how it's written, and this is how it's written as well, so it's not like a new thing. And then I have my opcode here, and I have the function here. I think now we are ready to start solving. So remember, wait, so the answer is gonna, oh, sorry. The answer is gonna be over here, and a hexa number always starts with 0x, so that's your first step. And then we're gonna see the opcode. As you can see, sorry, let me delete everything here so we can start on a clear situation. Okay, as you can see here, the opcode is 0, as I said earlier, and this means it's gonna be 0, 6 bits. Why? Because my opcode is from 31 to 26, and this means it's 6 bits, so all of this is gonna be 0, 6 bits. Okay, so going back to my text, yep, I'm gonna have, oh wait, sorry, no, that's okay. Let's delete the hexa number right now, and let's focus on writing the opcode. So what do we have? We said it's gonna be 6 zeros, right? So 1, 2, 3, 4, 5, 6, and this is how the opcode is written. But since we're gonna change it to hexa number, like, right, our code is gonna be changed to hexa number, we should put spaces between each 4 digits, so it is easier for us to change it later. and not to make mistakes. Let's do it again. 1, 2, 3, 4. Is it full? Not yet. No. The opcode is 6 bits, so we still have 2. We put space and then 1, 2. So oops, and then we stop. Alright? Gonna put it here, and then we go next. We have RS, opcode, then RS. RS takes 5 bits, so we will have 5 bits over here, 5 numbers over here, and then we're gonna look. RS stands for T1, and T1 is 9. How is 9 written in hex? It is basically, oh wait, yeah, I think I need to do something. I'm gonna do it and come back to you guys. Alright, all I did is just I wrote, as you can see, oops, not this one. Change the color. Yeah. Oh, yeah. All I just did is to translate this number 8 to hexa number, this 9 number to hexa number, this 14 number to hexa number, so we don't waste the video time, the video time, yes, so it's easier to understand. So coming back, what we said earlier, we finished opcode, now we go to RS. RS is T1, and T1 stands for 9, and 9 is written in this way, in hexa, in bits, so in hexa, in a binary, sorry, we change it to binary, and then we go back to our number here, right? It's not 4 digits yet, like these two are not 4 digits yet, so I'm gonna continue. So we have 0, 1, and then 0, 0, 1. So what did I do? I just took this 0, 1, 0, 0, 1, and then I put them here because this is opcode, right? I'm just gonna write op because it's clear. Yeah. And this is going to be, this is the opcode, and this is going to be RS. And then we're gonna do the following with RT, RD, shift amount, and function. So I'm just gonna do it and come back to you guys. Okay, so this is gonna be RS, right? 0, 1, 0, 0, 1, which is 9. 0, 1, 0, 0, 1. That's an RS. Also, as I said earlier, make sure that you keep spaces after each 4 digits. Just keep spaces so we can change it later easily to hexa number. So what do? We take the code, we change the code to binary after seeing this instruction or format. We change it to binary number, which is what we're doing right now. And after we change it to binary, we're just gonna change it to hexa number, which is gonna be the code that we want, which is the end result. So let's go back. We have RS here, right? And then we have RT here. RT goes to T6, and T6 is 14, and 14 is written in this way, and this starts from here. So 0, 1, 1, 1, yes, and then 0. It's cool. RD is over here, T0, 8, and it's 0, 1, 0, 0, 0, and it's also 5 bits, because as we said earlier, RD, RS, RT, RD are 5 bits. Shift amount is actually 5 bits, and function is 6 bits. So not 6 bits, not 6 bits, it's in hexa number, but it's actually 6 bits. So yeah, you can think of it like this. So we have 0, 1, 0, 0, 0, 0, 1, 0, 0, 0. Okay, that's cool. Alright, so we are done with this. We are done with this. Wait, yes, we are done with this. Oops. Now we go to shift amount. Do we have a shift amount here? Like, is there SHMAT? SHAMT? There is no, so we consider shift amount as 0. So basically, I'm just gonna write 5 zeros because shift amount is made of 5 bits. Okay, oops, not here. No. Okay. 1, 2, 3, 4, 5. Cool. And then let me just color it in a different color so you guys don't get messed up. Alright. And then RS, RD, and this is shift. Oops, no. Give me my favorite color. Shift amount. And now we go to the function, which is more important part. So basically my function here is 24 hex, right? Let me just fix this. Yep. My function here is 24 hex, right? So basically to change it to binary, we're just gonna write 0, 0, 1, 0, 0, 1, 0, 0, right? This is gonna be 4 and this is gonna be 2. It's correct, but there is a small mistake. We only have 6 bits left, which is 6 bits left, but in this hexa number we have 24. which is gonna be 0 0 1 0 0 1 0 0, which is 24. But what we do is actually we just remove the first two bits because they are useless. Our hexa number will, like, this number will never be more than two binary numbers. As you can see, we have only two binary numbers. The other ones are gonna be deleted because it's too much. We don't care about these two bits. We're not gonna access them anyway. So you just can't think of this. You're just gonna take this number as it is, and we're gonna put it here. And this is gonna be 6 bits. 1, 2, 3, 4, 5, 6, which is, oops, yeah, which what we said in the beginning, it should be 6 digits. Alright, so we go back, we come here, 1 2 3 4 1 2, we add the 1 0 and then 0 1 0 0, and this should be our binary code of changing. This should be our binary number after changing the instruction to a binary number. Let me just write this in a different color as we said earlier. We're gonna say this is as hex, no, op, this is function, which stands for func, function, shift amount, rd, yeah, that's 1 2 3 4 5, yep, rt, cool, rs, nice, and then opcode. After this, let me go down a little bit. We're gonna change this number to a hexa number, right? So we will, wait, we're gonna change this to hexa number, and this is gonna be our final result, which should be, first of all, we start our hexa number with 0x, and then this is actually 0, this is 1, right? This is 2, 0, 1 2 4 8, but the only one in this 4 digits is this one, which is 2, so this is 2, and this is gonna be a b c d e, this is gonna be e, and then this is gonna be 0 1 2 4, this is gonna be 4, shift amount is 0, we said 0, this is gonna be 2, and this is gonna be 4. So the function, just a simple hack, the function is always the same. Look, function is 24, function is 24. As you can see here, we didn't do magic, we're just gonna copy it, right? Now you can just write this inside this number, and this should be your total answer, or your total final answer. So we have 0, wait, let me just put down here, cool, wait, we have 0 1 2 e 4 0 2 4. There should be 8 numbers, 1 2 3 4 5 6 7 8, and this should be your total, your final result. Let's go check it here. Execute 0 1 2 e 0 1 2 e 4 0 2 4 4 0 2 4, and yep, this is the correct answer. I hope you have learned. Now we just go to the exceptions. Okay, I wouldn't call these exceptions, but I need to clarify more. As you can see here, we have RD, we have RT, but there is no RS, right? No RS. We have actually also shift amount. We have shift amount. This is shift left logical, shift right logical. So shift left logical, it's multiplication, and shift right logical is division, but it's in binary. You can Google it more, you can look at it up more. I'm not gonna waste time on it. So the shift amount is, oops. So as you can see, that actually should be and, yes. So all of them are just gonna be written in equal to 0 5 bits. So all of the 5 bits are gonna be written in zeros. for RD, RT, and shift amount, because we're just gonna use register RS. And that's for the exceptions. And now we are actually done with this. Let's just go and start convert hex number to a machine instruction. So as you can see, this is the number what we got, right? From AND T0, T1, T6. So I'm just gonna like turn it back to T and T0, T1, T6. All you need to do right now is just to take this one, which is like how to change it, the R-type format, like this one, and the number that you want, the hexa number that we want to change it to an instruction machine code, and then do the following. So we know that the opcode is 6 bits, we know that the RS is 5 bits, RT is 5, RD is 5, shift amount is 5, and function is 6, and also like the last 2 bits are not gonna change, right? But we wanted to change it to we want to change it to a machine instruction machine code, so therefore like we're not gonna use the 24 right now. So basically we're just gonna change this number to a binary number. Let me change it and come back to you guys. I thought it's better to show you how to change it, so you don't raise some questions in the future. So we know that this is 0, and we know that like these zeros are made of 4 bits, 1, 2, 3, 4. Same goes with this one, it's gonna be 0, 0, 0, 1. Same goes with this two, is gonna be 0, 0, 1, 0. So all am I gonna do? I'm just gonna take the text, right? I'm just gonna write it 0, 0, 0, right? The 4 0, 0, 0, as you can see, these are the zeros. I put it here, right? And then go back here, next 0, 0, 0, 1, next 0, 0, 1, 0, and just so on, you know. Take the number in a hex, this is a hexadecimal number, take each hexadecimal number, change it to binary form, and then write it down. So I'm just gonna write them down and come back to you guys. Alright, now I'm done. Now I'm just gonna show you, it looks like magic, but like trust me, it's so fun. So we know that the first 6 bits are gonna be opcode, right? So 1, 2, 3, 4, 5, 6. And this is our opcode, and it's actually all of them are 0. So a tip, when you see that your opcode is 0, it means it's an R-type format function. It's an R-type, it's a R-type format instruction, and this means that you're gonna deal with regular instructions. Okay, that's for opcode. Next, we have RS, and it's made of 5 bits, so 1, 2, 3, 4, 5. We're gonna stop here, and this number is equal to, wait, opcode is 0, right? RS is equal to 1, 2, 4, 8. 1 plus 8 is 9, so RS is equal to 9. And this is register number 9. And then we just go do the same thing with this, with the RT. RT is 5 bits, so 1, 2, 3, 4, 5. We stop here, and then we take this number, we change it to a decimal number. We have 2, 4, 2 plus 4 is 6, 6 plus 8 is 14, so RT is equal to 14, right? And then we just do the following with the RD, which is gonna be, I believe RD is gonna be equal to 8, and then we have shift amount is gonna be equal to 0. As we said earlier, there is no shift in the function, there is no shift here, right? There is no shift here, like, as you can see in this function, there is no shift amount. All right, coming next, we have function. And now when you see the function, right, when you see the function, change it to hexa number. So how do you do this? You're just gonna take the first 2 bits here. This is 2 and this is 4, right? Cool. 2, 4, and then you're just gonna go to your green maps sheet and you're gonna look for a function. You're gonna look for a function that has 24 as a hex. And let's go down a little bit. As you can see, we didn't find any because I just skipped it. 20, oh wait, it's not this one. It's not this one. Why? Two stuff. First of all, we said our class is gonna be I-type, but this is not convenient. We also said that R-type instructions, their opcode is 0 and they have slash, but this one doesn't have 0, neither have a slash, so it's not an R-type, so it's not what you're looking for. We are looking for an opcode with 0 and then function with 24, which is this one, which is and. So you know, like from the function, you know that this code is this instruction is an and instruction, is an and instruction. And now we're just gonna know what is RD, what is RS, what is RT from this table over here by taking the number we already wrote. So as you can see, we have 9, we have 14, we have 18. So what does that mean? Let me write it here. What is 18? Wait, let me delete this. We said that 8, oh yeah, we have 8 here, right? As you can see, the number is 8. So this is gonna be T0, right? 8 T0, 8 T0. And same for the rest. We have RD as 8, which is T0. So basically RS is gonna be T1 equal to, wait, there is no equal to, it's 9, yes. And then we have RT, which is 14. 14 minus 9 is 5, 5, yes. 9 plus 5 is 14. So therefore it's gonna be, this is T1, just add 5 to it, it's just gonna be T6. As you can see also, if we go here, oops, if we go here, we have T7 as 15, so T6 is gonna be 14. Yep, so this is T6. And now what do we do? So we said already that it's gonna be AND function, right? How did we know this? We just go here, we looked at the opcode, it's 0, we looked at the function, it's 24, and 24 means it's and its operation, the AND function operation and instruction operation is gonna be written in this way, right? So RD first, right? RD is the first register. Where is the RD? We said RD is gonna be, so this is the opcode, this is RS, this is the RT, and this is RD. RD is 8, right? RD is 8. What is 8? We said 8 is T0. T0, so we're just gonna basically write $sign T0, comma, and then next, come back here, we have RS, right? RS is gonna be the first operand after opcode. So we have opcode here, six numbers, and then we have RS here. RS is 9, and basically 9 means T1. So we're just gonna write T1. Next, we have RT 14, and 14 is T6, and we just write T6. And it's the same, right? As you can see here, T0, T1, T6, 14, 9, 8. T0 is, wait, let me write it in a different color. This is T0, which is 8. RS here, which is 9. 14 here, which is T6. So basically 8, 9, 14, 8, 9, 14, and the code is 012E4024, which is the same as this, 012E4024. And this is your final answer. Thank you so much for today. I hope you guys have learned. See you next video. Take care.